How many of you have deployed IPv6? If you have, I'm pretty sure you're using some type of transition mechanism, such as dual stack, tunneling, or translation. What are you using? Think about it. Think about what you had to go through in order to make it work. We have these various options available to us. However, what is best for your organization? Based on what you're trying to accomplish, how you have your environment set up right now. For example, dual stacking. What does that mean? It means that we're running both IPv4 and IPv6 protocol stacks on every single device and link within our infrastructure. So it means that our entire infrastructure has to support both protocols. The services that we offer, the features, the applications have to support both protocols. So this may require us to do expensive or excessive upgrades to our environment. Maybe even a complete redesign is required. So it doesn't allow us to easily integrate both the IPv4 and IPv6 environment. We're really still having two different environments, one completely IPv6 and one completely IPv4. Therefore, users running IPv6 can't access IPv4 resources. So it's important that the resources are both IPv4 and IPv6 enabled. Tunneling is another option we have. With tunneling, what we're going to do is we're going to take IPv6 packets, for example, and encapsulate them so that way there we can transmit them over an IPv4 network. What this allows us to do is have IPv6 deployed in certain portions of the network and IPv4 deployed in certain portions of the network, and then use tunneling to make sure that the IPv6 traffic can get over IPv4 networks and IPv4 traffic can get over IPv6 networks. However, what does that do to the end resources that we have? Well, can an IPv6 user access IPv4 resources? No. Can an IPv4 user access IPv6 resources? No. So what's happening here is instead of dual stacking every single device in the environment, we're really only dual stacking the tunnel source and destination points. That's what's happening when we're doing tunneling. So with that in mind, we, again, aren't able to easily integrate both an IPv4 and IPv6 environment using a tunneling solution. So if we want to easily integrate both an IPv4 and IPv6 solution without having to worry about every single device in the network running both IPv4 and IPv6 and every single resource being IPv4 and IPv6 enabled, we can use translation. So what is translation? Well, are you familiar with network address translation, NAT, for IPv4? Well, that's what I'm talking about here. But in this case, we're translating what? We're translating IPv4 packets to IPv6. We're translating IPv6 to IPv4. What would this give us the ability to do? It gives us the ability to have our IPv6 users access IPv4 enabled resources. So we don't have to dual stack clients. We don't have to dual stack our applications and our resources inside of our organization. So no real change to the existing infrastructure. We just have to make sure we have some router that can support this translation from IPv6 to IPv4 and back. We don't have to worry about our resources and our services and our features throughout the network supporting both protocols. Just that router is going to have to be able to support both. So very, very minimal upgrades, very minimal redesign to no redesign at all. And then it allows for a gradual migration from IPv4 to IPv6. You see, with dual stack, is it a gradual migration? No. No, not at all. Dual stack means here's IPv6, here's IPv4. If we have certain clients running IPv6 and they need access to a certain resource, it's going to be running IPv6 as well. Tunneling is the same thing. Tunneling still keeps everything separate. It's just allowing us to transfer those IPv6 packets over IPv4 networks and vice versa. But here, with the translation, we can have that gradual, slow migration. So we set up a little pocket of IPv6. We have a router translating those IPv6 to IPv4 packets to access resources and translate them back when they return.